Good afternoon, everyone. Welcome to Mindful Mobility Tech Talks. This is part of a 5-part series so far. Our series is sponsored by Green Transportation Summit and Expo, the West Coast Collaborative, and the Mobilize California Driving Change. This is titled Seminar 2, Addressing Workforce Fundamental Training for Electric Vehicles and ADAS Systems. Next slide. Our sponsors are Clean Cities of Treasure Valley, Idaho, Clean Cities of Columbia Willamette, Clean Cities of Long Beach. We have Future Tech as a sponsor, Diagnostic Network, Chabot College, Central Oregon Community College, and the National Science Foundation. Next slide. My name is Ken Mays, and I've been working in the automotive industry for a long time, longer than the history of man. So the things that I am really proud of is working at a Central Oregon Community College here in Bend, Oregon. And I have a fellow instructors and staff who allow me to do other things such as work with the National Science Foundation on grant projects. I have a great staff, and it takes that to be able to step outside of your primary job. The National Science Foundation project has a title to it. It's the Northwest Engineering and Vehicle Technology Exchange, and we are developing advanced vehicle technician standards for electric vehicle and high pressure, high voltage systems. So the grant is ongoing. It's been developed, has about a 4-year span. We are getting very close. And if you want to know more, you can always email or contact the web folks, and they'll transfer your information questions to me. But there are great things that are happening. I'd like to go to the next slide, and we're going to do a little bit of housekeeping before we get started. As you are chatting with each other, let's go ahead and use the chat box. If you have questions, use the question and answer box here, and I'll be monitoring those. I'll be sharing those with Dr. Quarto, our speaker today, and we'll try to get to all of those questions. But make sure you put those in the question and answer section. The recording for today will be available for all attendees. So you'll get that email and attachment. But we also have a feedback at the very end of this seminar, and we sure love to have that feedback from you. Next slide. We're going to have 2 polling questions. Everybody get ready. Here we go. First question is, my company is currently working with vehicle electrification systems. Yes or no? Maybe you are planning. So go ahead and answer that one. And the second one, for your company, where do you plan to have your technicians trained on vehicle electrification systems? And you see the options there. I'll give everybody about 20, 30 seconds. So the 76% says that you are currently working with vehicle electrifications, and 14% say no, and 11% say you plan to. For your company, where do you plan on getting training for vehicle electrification systems? 49% say local community or technical college, 14% manufacturer-specific courses, 11% intensive on-site training, example, 1-week training at a specific location, 22% online training, and 5% are saying, I don't know where to start. Always leave your email information if you have questions or no, but I think today you're going to get some ideas on where to start. Next slide. It is my privilege to introduce Dr. Mark Quarto. He represents Future Tech, but he has a huge background in vehicle electrification. Let me explain. Dr. Mark Quarto has supported alliances and customers in the development of electric propulsion and energy management power systems for over 33 years. His former work for 28 years with General Motors consisted of developing propulsion and battery pack systems for the General Motors EV1, the Chevrolet Tahoe Yukon Hybrid, the Chevrolet Spark electric vehicle, the Chevrolet Volt, and numerous demonstration fleet electric and fuel cell products. His specialty is developing diagnostic systems, diagnostic information, and pioneer control systems that permit innovative diagnostic techniques and diagnostic tool development. His passion for educating and training the next generation of automotive technicians and engineers has connected him with many international educational projects. Dr. Quarto provides instruction on hybrid, electric, and plug-in vehicle systems for the Society of Automotive Engineers, the OEMs, the Tier 1 suppliers, and in the college environments. He is a patent holder for electric drive systems, testing tools, and battery testing processes. Dr. Quarto holds a doctorate in technical education on hybrid systems from Nova Southeastern University, master's degree in electric machine technical education, and bachelor degrees in electrical engineering and automotive technology. And I will add that if it weren't for Dr. Quarto, my college would not be as advanced as it is in training. I encourage that you plug into Future Tech resources. Anybody who's looking at how do you get started, I want to introduce my friend, Dr. Mark Quarto.
Hi, Ken.
All right, you look good there, Mark.
Oh, I appreciate that, Ken. I'm only trying to emulate you.
Okay, I'm signing out of here.
Okay, well, great. Well, good afternoon, everybody. This is Mark Quarto, and thanks for joining us today. I'd first like to thank the Clean Cities and Brian Trice for the opportunity to present today and provide what I feel is an important message to everyone who's involved with the transportation space. Second of all, Ken, I'd like to thank you for the kind introduction and providing a background for the presentation and discussion. And special thanks to Maddie Resnick for managing the session today. Appreciate it, Maddie. I know it's a lot of work, so I appreciate you managing it. So with that, what I'm going to do is I'm going to share my screen and we can get started with the presentation. Okay, everybody should be able to see, and I'm going to go ahead and hang on just a second. I'm going to kill my I'm going to kill my video. There we go, so you don't have to look at my mug the whole time. All right, here we go. All right, everybody should see my presentation now. We'll get started, and the topic is going to be preparing your workforce for tomorrow's transportation industry. And this is going to be pathways in preparing technicians, and I would say instructors as well here for the challenges of battery electric vehicles. And I'll just say battery electric vehicles is really maybe kind of a general way of saying all of vehicle electrification, whether it's battery electric vehicle or it's hybrid electric vehicle or fuel cell, anything within that space is what we're really after today. So the presentation outline, we'll take a look at it here, starting with industry and product trends. That'd be the driving forces of them. Industry needs, this would be taking a look at the ASE benchmark data. We'll take a look at what legacy knowledge and technology transfer are and what they mean to not only technicians, but also instructors, and even, quite honestly, to those board members that are on colleges and universities to know how they're going to plan, key technologies to master and the training paths to master, and then opportunities expanding within the technology, and then finally, I'll take a look at the summary. And what I'd like to do here is also, I'd like to frame my presentation by starting with the premise that although this presentation focuses on preparing technicians for vehicle electrification, this message also applies to automotive instructors that will be mentoring and instructing students. There's no way to get around this. This will require significant instructor technical updating. And quite honestly, you'll see within the presentation, a lot of what I have here is going to port over to ATIS systems. And ATIS quite honestly, is probably an iterative system on the traditional vehicles, but and it's not quite as impactful as electrification. But a lot of what I have to say today within the presentation will apply to ADAS. Additionally, I think the presentation will also have some touch points for fleet managers, college administrators, and college board members to assist them in understanding that there's a real change underway in transportation space that's going to require funding, planning, and execution of programs necessary to support the current and future vehicle electrification, education, and training programs. Without the managers, board members, administrators, we're going to go nowhere. So they really need to be plugged in to understand what's happening in the transportation space. So let's take a look at the industry trends in vehicle electrification. First of all, let's take a look at the derivatives. You really have four major derivatives here. You've got hybrid electric vehicles, which are HEV, extended range electric vehicles, which are EREV, plug-in hybrid electric vehicles, which are PHEV, and then battery electric vehicles, which are BEV. So between these technologies, the one I don't have in here is fuel cell, but fuel cell also goes along here, and that all these technologies have similarities in them, and their core systems really mirror each other. So if you understand the core technologies underneath each one of these derivatives, you're going to have a good shot at being able to blend into vehicle electrification. So let's take a look at light duty truck. What's happening today is that you have many companies that are cropping up. Ford, of course, is getting into the all-electric vehicle pickup. Rivian, which is a company that has some of my former counterparts at General Motors that work at Rivian now. Hummer is coming out with their brand. So if you look at it, even it's not just the automotive space, it's also the light duty truck. And as we'll take a look at a little in a few slides here, you'll see that it also ports over to medium and heavy duty. But you've got a lot of new companies, Bollinger, Nikola, Tesla, of course, is in the electric space with their Cybertruck, and then Lordstown Motors, which is a new company that's cropped up. They just have taken over or moved into a former General Motors facility in near Youngstown, Ohio. So that would be Lordstown plant. So again, it's not just automotive, it's also light duty truck. And then of course, this is also moving into the medium and heavy duty fleets. I have clients that are working on heavy duty truck. This would be like class 8 trucks that are over the road tractors that are all electric. You've got medium duty vehicles like UPS that are moving into the electric space. And then of course you got Nikola fuel cell truck. So plenty of vehicle electrification going across the board. Again, whether it's light duty, medium duty, or heavy duty. And this is moving very quickly because of the mandates that are out there for OEMs to move into fewer emissions, fewer greenhouse gas, and higher fuel economy. Autonomous vehicle, of course, whether you want to talk about light duty vehicles, or there are specialty vehicles like we have on the screen here with Ali AV autonomous vehicle, which is made by Local Motors. And then you've got Navia, who is another company. These are vehicles that are currently running in different cities. And right now they are moving from a driver that is currently sitting in the seat and monitoring the vehicle. Eventually these will be completely autonomous, and they're moving there very quickly to provide shuttle services within cities, townships, and so on. And then you can even get into boats. Boats are now going electric very quickly because there's a lot of mandates out there now that there are certain lakes that will not permit either diesel powered or gas powered vehicles. They either have to be sailboats or electric because of emission. So there's a lot of electric boat companies that are moving into that area. You've got one company called Torqeedo, who is has been moving into the space very aggressively. If you look right here, and let me kind of get my pen going here because I'll be using my pen during the presentation here. But if you look up here in the upper right hand corner, you can see that there is a this is the battery pack right here that is in this boat. And that is a BMW i3 battery pack that's sitting in an inboard boat. And so that boat is being run by electric. And unlike the old days where, maybe you could run 10 or 15 minutes on a battery on the boat, you can now run for hours on a boat and run them fairly aggressively because there's enough energy density in the battery pack to be able to do that. So Torqeedo is into outboards, or it's also into inboard motors to be able to propel the boat. So again, it's not just light duty, heavy duty vehicles. It's now moving into the boat space. Also, aircraft is moving very quickly into electric. There are many, many electric aircraft companies out there today. They go anywhere from the typical 4-passenger, 2 or 4-passenger plane, and they can move into airplanes or aircraft that are into 10 to 15 people on passenger. So whether it's boats, cars, whether it is into light duty, heavy duty, we're into the vehicle electrification space. So it's not just wheels on the ground anymore. Now it's up in the air. So when we take a look at the aircraft companies, these are some of the big ones. I haven't gotten them all on here, of course, because I didn't want to sit there and go page after page through this, but you've got Rolls-Royce, Airbus, NASA. You've got companies that are like Ampere, and there are others that are out there building aircraft. And so right now they are running routes. Right now they are short routes. Some of them are only 100 miles, maybe 150. There are some aircraft companies that are currently running some routes that are up to 500 miles on their aircraft. So they're still getting FAA approvals, of course, to run the aircraft electric, but that is happening very quickly. Also, you've got stationary power, and you've got some companies. I've just got 2 of them up here that are into stationary power. One of them is going to be BMW, offers their system. You can see there's a battery pack over here on this wall right over here, and then they've got a power control system here. Tesla with their power wall, again, they're taking basically a battery pack and hanging it on the wall. And that provides either, there's a couple different ways of doing it. You can either have backup power to the home, or there are some homes with enough battery packs in them that they don't use utility power. They're either charged by solar, or they're charged by water power, which would be water generation, something like that. So some of them are completely unhooked from the grid. Also, diesels are on the way to be phased out. This is one reason why companies like Cummins, I've got Cummins right up here, where they're starting to look at phasing the diesels out. Many diesel engine companies are currently on their last development engines that they're going to be developing. And then, of course, those will be going out into the field. But they are quickly now pivoting out of diesel and getting into electric power. So diesels are, I'm not saying that they're going to be phased out tomorrow. Of course not. They'll still be around 10 years from now. But the point is that they are ending their development cycles for the diesel engines, and they're moving into electric. So if you have students that are technicians that are going to be out in the field and they're very young, they're quite likely going to see quite the change when diesel gets phased out and companies start going more into electric drive systems. So again, it's not just light duty, it's going to be aircraft, boats, it's everywhere. So what are the forces that are driving us to EVs? And I could probably spend an hour going through this here, but I'm just kind of going to give you the very quick overview. We know that there are 3 things that really drive the OEMs. It's not fuel prices. They don't care about that. What they are interested in, though, is greenhouse gases and ZEV credits. So if you take a look at corporate average fuel economy, even though they don't care about fuel prices, the corporate average fuel economy is something they do care about. So if you take a look at what happened between 1990 and 2010, the target was 27.5 miles per gallon with their corporate average fuel economy. And then once you get into 2025, if you include light duty truck and passenger car, the fuel economy has to be approximately 49 miles a gallon. Greenhouse gases have to be reduced, of course. And then there's something called ZEV credits and then multipliers. And I'll try to do this very quickly. But in 2025, you've got approximately 22% of the vehicles that are sold by the OEMs have to be zero emission vehicle. Now there's some ins and outs to that law, but basically what I'll say is 22%. There may be some plug-in hybrids that are in the mix here, percentage of those, but for the most part, it's going to be zero emission at 22% by 2025, which means they have to be able to meet that mandate. Now, in today, there's something called a multiplier, which means that if you have a certain percentage of vehicles that you're producing that are zero emission vehicle, you have a multiplier. Let's just say the multiplier is 1.2 or 1.5 for those vehicles. That means that whatever you produce for the zero emission vehicle, you get to multiply that times 1.5, and that gives you your overall number for the number of credits that you're going to get. The problem with these credits is that as you march toward 2025, those credits start going away. And also the multipliers go away, which means in order to hit your fuel economy number, which we said was like 49 miles per gallon for passenger car and light duty, that means you have to produce vehicles that are going to be able to hit that number. And the only way to do that really is to electrify the fleet to be able to get your equivalent number of fuel economy up. So, and again, once you start moving past 2025, the credits continue to dwindle, multipliers continue to go away, and you're really dependent upon your zero emission vehicles to get your fuel economy numbers and your greenhouse gases down. Also, if you take a look at some of the efficiencies, and these are just general numbers, these are plus or minus probably 2 or 3 percentage points, but internal combustion is probably about 25% efficient. That is mode dependent, depending if you're accelerating, cruising, decel, it's mode dependent. Diesel is 35%. Again, it might be a little bit more than that or a little bit less depending on the engine. The fuel cell vehicle, the Toyota Mirai, is about 64% efficient, which is very good. And then you get into electric propulsion, which is about 85 to 92%. And Tesla currently owns the highest percentage on efficiency, although others are catching up quickly, but they currently own that percentage. So that percentage is based upon the battery pack, the power inverter, and the electric machine. You take the percentages of all three of these, then multiply those together, and you'll get your final number. So you can see with electrics that you have very high efficiency, which would push your equivalent numbers up. Equivalent means your kilowatt hours of the battery pack, what is that equivalent to in fuel economy? And there is a formula for that, which I won't go through today, but there is a formula for it. And so you reduce the greenhouse gases, so you get plenty of credits for that, which is very good. But like I said, as you move toward 2025, those credits and multipliers start going away. If you take a look at where we're at with vehicle electrification technology, that would be VE technology, which is vehicle electrification. You can see up here that where I've got that, you can see that oval right there. That oval represents probably where we are today. We're still in the early adopter stage. So right now we're there, but it's going to quickly move into early majority. Now, some of the things I've got up here to give you an idea, this is just benchmark, where the iPhone is today, and this chart is probably about 2 years old, maybe. The iPhone is still right here in the early majority. It still hasn't hit its peak yet. And that, of course, came out in 2007. You can take a look at YouTube up here. That came out in 2005. That's about at the peak of its adoption right now. And then on this side over here, you get into the late adopters. That's people that are still either haven't adopted it or they just adopted it, which like Gmail goes back to 2004. Then TV goes back to 1925. You can see that. And the newspaper back to 1690 when you got in the Gutenberg press. So we're still fairly early yet, but this is quickly moving into the early majority space. And like anything else, the earlier you get into it, the better off you are as the technology continues to roll out. So let's take a look at the feedback from the OEM and the aftermarket technicians and owners. This is the ASE Training Managers Council survey. You might find this interesting because this is a benchmark that's done every year by the ATMC. And you can see right here, this is the OEM. This is what the OEM says that their training needs are. And what's interesting is that there were about 5,000 people that responded to this survey. And of course, a number of them were OEs. And you can see that at the top here for what their needs are is electrical and electronic training, and also hybrid and EVs, even though there are a number of other things underneath that are more traditional type of technologies. You can see that electrical, electronic, and then hybrid and EV systems rank at the top. Also, you can actually break these apart. You can actually break electrical and electronic apart because they're not the same thing. They're not even close to being the same thing. But actually, I would say that if you broke these apart, electrical would probably be third. It'd probably be underneath here, and then electronics, and then hybrid and EV systems would be underneath that. So you can see over here that there's quite the majority of OE technicians that feel that, and OEMs, by the way, feel that there's a need for training in the field with their techs. If you go to the aftermarket, it's interesting, it flips. Now you've got the hybrid and EV is at the top for the aftermarket training needs, and then you get into electrical and electronic, that's second. So either way, whether you're looking at technicians in the OEM or the aftermarket, they're really after the same thing. And again, I would also take this and separate this out, because electrical, electronic are completely different. Electrical is going from, let's say a controller, the connector of the controller going over through a wire to another connector that connects up to something else. That's electrical. Electronic is what happens inside of the electronic box, and I would consider software and firmware, because that's what runs the controllers. I would consider that as part of electronic. So let's take a look now at where we are today with what we call legacy knowledge and technology transfer. And I'd like to define these because it's important that we do define them, because they're really the overarching inhibitors for learning vehicle electrification. So legacy systems, what they are is you're utilizing your existing knowledge and your experiences to learn something new. In other words, technicians have, and I would say instructors too, it's not just technicians. I'm going to have, remember at the beginning of this, my premise was also instructors here, that, we, and I'll include myself in this, we all rely heavily on what we have learned in the past. And this is very true. This is how we learn. We iterate, we learn, we leverage, we gather what we can for what we know. And then what we do is we try to apply that to what we're going to learn as something new. So we've got lots of legacy knowledge with internal combustion engines and diesel. The problem is that we don't have that with electrification. And this becomes a real sore point on the training side, because there's really nothing to leverage. If you get into another overarching inhibitor, it'd be technology transfer. Now this is totally new knowledge that needs to be learned without the benefit of previous technical knowledges or experiences. So if I went back to legacy knowledge, we're saying that there's really not much we can port over from traditional vehicles over to electrified vehicles or hybrids or fuel cell. And the same as technology transfer, because everything that we have done with traditional vehicles have either been 12 or 24 volt systems. So again, we've relied heavily on what we've known, but again, this doesn't really apply over to the high voltage systems that are on electrics, hybrids, and fuel cell. So if I take a look at what the technology transfer is, if I take a look at traditional systems, and I won't name all these off, but if you take a look at the traditional systems we have here on the left, you can see that these are all the things that we're used to with traditional systems. It's pretty straightforward. It's been there for a long time. When I take the traditional system and then take a look at battery electric systems, the only thing that really ports over here are the 12-volt accessories and then some of the braking functions, although the electric propulsion system does most of the braking while you drive your electric or your hybrid or your fuel cell vehicle. So, we're basically turning the drive motor into a generator. You may have more than one drive motor, but usually the regen comes from one of those. And that's for stability, to keep stability in the vehicle. But when electric braking is done, that's done through the drive motor that turns into a generator, and your friction braking really isn't working for the most part. There are some systems that use the rear brakes during regen braking, some to a lesser degree, some that have a four-wheel system, which means you have electric motors in front and the back. You'll end up using the rear motor somewhat as well. But that might be the closest that you get between electric and traditional. So there's really not much that ports over. So if we take a look at the core traditional power systems, you can see this is just your traditional vehicle. You've got some type of engine in here, where, again, whether it is internal combustion or diesel, and then you've got all of your other systems that are laid over the top of that. So this is what we've been dealing with for quite some time. And it's very familiar with most people that are at a college instructing, or technicians that are working on vehicles, or even, quite honestly, vehicle administrators that may know something about automotive are probably at least comfortable with knowing that there are engines under the hood, there's transmissions, there's fuel pumps, and so on. But again, this landscape is changing very quickly. So if you take a look at the core systems that are on an electric, and this is just a few of them, we're going to get into them a little bit more here, but you get into everything from your electric drive motors all the way into all your power electronics, your cooling systems. You may or may not have a transmission. If it's an electric vehicle, it's really a drive unit, not a transmission, unless there are some specialties out there that may have a two-speed system in them. But for the most part, electrics have a drive unit. They don't have anything that shifts. You just step on the pedal and you go, and there's no shifting. And then, of course, you've got the battery pack in here, which as of today, we've got many, many different flavors of lithium that are out there today. There's all kinds of flavors. It's not just like one lithium technology. There are plenty of them, whether they are an NCA technology, that would be nickel, cobalt, aluminum, that's used by Tesla, or a nickel manganese cobalt and NMC technology that's used by others. These technologies all have their own operating quirks, and they will also display data, or can display data differently on the scan tool. If you're a technician, you'll see differences in the scan tool. So, and these things change from year to year. There are companies that are currently have plans in retrofitting battery packs to newer technologies when the battery packs go in for repair or remanufacturing. So the bottom line here is that when you get into the battery pack side, it's going to be very difficult for a technician to really know what's underneath the cover of that battery pack, unless they have some type of background in it, so they can kind of pick it off and read up on it. And once you have a background in it, you really kind of know what to expect from them. But if you don't have that, you won't know what the data should look like when you're looking at the scan tool. I know you have diagnostic trouble codes, and I appreciate that, but there are other things to look at on a scan tool other than just DTCs. You're looking at data too, and you're trying to find out whether it's using a scope, a scan tool, or some type of meter, if that device, whether, again, scope, meter, or scan tool, is giving you the right data. The diagnostics are getting better, but these systems are iterating so fast that the diagnostics sometimes don't keep up with them as they should, because these are not mature systems. These are iterating fast. The only way to get really super good diagnostics is you have to have a system that matures or iterates to the point where it levels off in its maturity. And right now, we're not even close to that right now. So the bottom line here would be that when you take a look at the battery electrics, or the fuel cells or whatever it is, you really have to kind of dive into this to find out what's there, and then how it should be operating, what things should I see. And then you can even get into the service side. You can get even there are more things to look at when you get over to the service side. So there's a lot going on here in this space. And right now there are all kinds of changes happening, and it almost takes pattern failure out of vehicles anymore. They're being updated so quickly that technicians may have to be used to dropping the reliance on pattern failure for the vehicle. So because the things are changing fairly quickly. So this really gets down. This is going to be a thinking person's game now on this, and they're going to have to be super lifelong learners, and they're going to have good electrical, and software backgrounds on these to really be able to keep up with them. So when we take a look at the common battery electric high voltage power systems, and again, a lot of this applies over to hybrid vehicle and fuel cell and plug-in. Starting in the upper left-hand corner over here, you can see that we've got battery pack modules. These can either be 8 to 800 volts, and I think there is a system out there that is now 900 volts, but I don't think it's been released yet. You go over to next over on the right here is a 3, 6, or 9 phase induction or permanent magnet electric machine. And notice I called it electric machine. I don't call it a motor, because an electric machine can do both. It can motor and it can generate. It can do both. So if you have something that can both produce torque for propelling the vehicle, but also regen power back into it, it's an electric machine. If it only does one or the other, like a table saw you have at home, that's an electric motor. Or if you have a portable generator, that's a generator. If they can do both, then it's an electric machine. Then you get into power inverters, which are 3, 6, and 9 phase power inverters, which are going to convert DC to AC or AC to DC. You've got some very sophisticated high voltage vehicle safety systems that are on board. There's an awful lot of them on board, whether you're talking about the manual disconnect, interlock circuits, bus discharge circuits, isolation fault circuits, and then there's DC and AC isolation fault systems. These are fairly sophisticated, and many of them are mandated. So that means that every OE is going to have them on their vehicle. You've got power conversion, which is your DC to DC converter. This replaces your alternator. This is going to take high voltage from the battery pack and reduce it down to low voltage so that you get it down to approximately 14 volts so you can run the accessories and the low power stuff on the vehicle. You've got battery pack cooling systems, which most of the time on battery electrics are going to be liquid, but they could be air if you get into plug-ins and hybrids. You've got high voltage electric cabin heating systems, which are anywhere from 6 up to 10 kilowatts of cabin heating. In the cases, if you get into some larger vehicles like buses, they can get into 20 and 30 kilowatts, that's a lot of heat. You've got electric air conditioning systems. The compressors are electric. Then you've got battery pack heating systems. So you've also got battery pack heating and cooling systems, although the battery pack uses the air conditioning system from the vehicle to cool it if you're using a chiller. And then you've got the high voltage battery charger, which either can be, at least most vehicles today have anywhere from a level 1, level 2, and level 3 charging. Some don't have a level 1, most do. Level 2 is like your 220 charging, and then level 3 is your fast charge, which would be your 480 volt charging. So, and this is DC, and this is AC down here. So that's what we have today with the systems that are on the vehicle. And these are all things that would be new to any technician. In some cases, they're new to instructors as well. When you take a look at the core power systems, looking at, this happens to be a Chevrolet Bolt, but what I've done is I've gone in here and labeled what these are. Anything from a DC to DC converter, which is up here. Whoops, sorry about that. DC to DC converter, which is there. Let me get my pen going again. You've got the high voltage distribution module, which is really your junction box. You got your 3-phase power inverter here, electric compressor, your onboard charging module, which is here. Again, your DC to DC converter here, your manual disconnect, your battery pack, which is your largest component here, your battery pack heating system, which is actually right in front here on this guy, your three-phase drive unit, which in this case, it's a permanent magnet machine. It's actually an 8-pole permanent magnet machine, or it could be induction machine with some vehicles, but this one happens to be permanent magnet. Then you got your cabin heater up here. That's a 7.5 kilowatt heater for the cabin. So these are all of the base systems that are on the vehicle, and of course, there's tons of data that run these devices and control them. And so we got hardware we're looking at here, but then there's all the electronics and software that are running underneath that are providing your controls for it. So these are the things that technicians and, again, instructors would really need to know, and quite honestly, something that administrators should know, because this is going to impact how the programs are funded and so on. So this presentation also has touch points for fleet managers, college administrators, board members, and so on. Again, this is going to require some planning for funding and the execution of the programs necessary to support the education and training program. So really, this goes across the board. This is technicians, this is instructors, this is automotive chairs, this is administrators, and this is board members. This is everybody. This is going to be a team effort to really get the technicians to where they need to go for learning the electrification product. Okay, I think we have a question. So Ken, is this you or Maddie?
I'm gonna step in here, Mark, and we had a comment earlier on, but I'm gonna hold on to that comment towards the end and ask you that. But I've got Kurt Shadbolt, my friend Kurt is here, and he's coming in with a couple of questions. I'm gonna ask them in order here. Do you feel, Mark, that the future EVs will transition into diagnostics that are more in line with what Tesla is doing, non-OBD2 driven diagnostics?
I would say that it's not going to be Tesla driven. I think there's something that has transcended Tesla already. I think the systems are going to go away from what we're currently doing with CAN systems today, and they're going to go over to Ethernet, which I know Tesla has Ethernet, but they also have CAN. But we're going to get away from CAN systems. We're going to go into more Ethernet systems, which means we have centralized controllers. There are some OEs that are already looking into this. VW is one, where they're all looking to get away from CAN and get into Ethernet because it's a faster it's a faster system. I know that there are OBD requirements that are out there for internal combustion engines, and OBD really doesn't impact electrics like they do gas or diesel because there's no fuels being burned. So I think that the diagnostics go well past where we're at today because there's the capacity to do it. And so I think that when you get into electric systems, electric vehicle or hybrid systems or plug-ins, but especially electric car, once you move away from the engines and once you move away from using bandwidth to run the engines, you get into all kinds of other possibilities, and you'd need Ethernet for that, like torque vectoring in a car where you put a car into a spin and you're using the electric motors to straighten the vehicle out rather than you trying to steer out of it. The vector control does that. And that'll be a system that's already added. I mean, there are some cars that already have vector control. Either they're cars that have currently just come out or they are coming out. But I think it's going to go, the diagnostics, to answer his question, it's going to go well past OBD. It's going to be into things that we haven't dealt with before with data. I think there's tons of data on the car that currently are not on the scan tool, and the reason that it's not on the scan tool, it's either one, it's not necessary for somebody to see it on the scan tool, or number two, there's just not enough bandwidth to run it. So I think that there'll be merit to looking at many more diagnostics that have nothing to do with OBD. And I think what they'll do is the word OBD is kind of they'll kind of take a back burner, and I think in the future it'll be more like just vehicle diagnostics. OBD was a stepping stone for these cars.
Next question is, what would you recommend that instructors start to do to address this new data-driven diagnostic process versus the OEM fault-driven diagnostics?
Well, it's a simple formula, and there's really nothing that is difficult about it. These cars are going to live and die with electronics and software, and you're going to have some type of background in electronics and software. I'm not saying that people have to be designers. I'm not saying they have to be software coders. That's not what I'm saying. What I'm saying is you're going to have a working knowledge of the devices and a working knowledge of software. When you have those working knowledges, you can then you can get more creative with what you do get from the OEMs. You can manipulate circuits better. In some cases, you can make your own tools if you need them. But certainly if you understand, as an example, how software is structured, and you actually code some software, you don't have to be a coder, but if at least you do some coding, you'll understand the mechanics of the software. And that really helps you with understanding maybe where, if something's not written in a diagnostic chart, you may be able to create something because you understand what's going on underneath it. And that would be, again, electronic devices or software, either one. So I think that electronics and software would be, there's no way around that. It just makes you a better diagnostician, and it makes you someone who would be more valuable. It really increases your value. The other thing I think that instructors will have to know is that they're going to have to know something about alternating current, and there's no way around this either, because the drive motors all operate off AC, your compressors operate off AC, even your diagnostic systems, quite honestly, internal to doing isolation fault detection, those are DC and AC driven systems. So again, understanding those circuits helps you understand what they're doing and how they're doing it, and it helps you become a better diagnostician.
Next question is, what is your response when OEMs tell fleets not to worry about training for high voltage systems when OEMs state they, quote, do not want the fleet touching the battery pack motor, unquote? Is this something OEMs will slowly let go of, not support after warranties are up, etc.?
Well, I think some of it has to do with the warranty period that the fleet has. If you're looking at the military, and I've worked with the military before, on their fleets, they get a 3-year warranty period. That's it. They get such a good price on the vehicles that the OEMs cut the warranty period down. So after 3 years, they're doing the work on it because their warranty period's up. And everybody kind of cuts their own deal with the fleet side. But I appreciate what the OEMs say. I'm a former OEM person, and but I think I know the OEMs would sure like to keep people out of their vehicles. I understand that, and they want to either send it back to the dealer or they're just going to send it right back to remanufacturer. But I think that fleets need to understand, and fleet technicians, for the most part, at least need a fundamental understanding of what's going on in there, because at some point in time, the spigot may be turned on to where they are going to be able to get inside and do that. And more is better. The more you know, the better off you are, because things change. The markets just change quickly. Look what's happened since the month of March with all the COVID related. Look at how that's impacted business and impacted everyone. And it can happen in a split second. Something could change. And I think this is the same way. The more you know, the more you're going to be able to navigate the waters when they do change.
Next question, does anyone outside of Tesla have technical training for Tesla?
I think the Canadians do some training on Tesla, but Quite honestly, and this is probably not something for me to say, but I kind of ignore Tesla because there's really nothing we can do with them unless you're within the Tesla ecosystem. So I appreciate their technology. Some of their some of their engineering is very good, but their systems on there are a known quantity. It's just that like the aftermarket can't do anything with them today because they outside of maybe the state of Massachusetts, but you really can't do much with them. So I know in Canada, they are doing a little more with them because I think when you go from country to country, there are some differences in the way that they handle their relationship with Tesla. I know that's for sure with every other OEM. So there may be some things within Canada, but in the US, it's kind of narrow with getting any type of support.
Well, here's a question that I wish I could answer, but what industry recognized electric vehicle zero emission vehicle certifications besides L3 are out there that we can augment community college transportation programs?
Would you repeat that again, Ken?
It's what industry recognized electric vehicle or zero emission vehicle certifications besides the ASE L3 are out there that we can augment community college transportation programs?
I'm not aware of any that are like certifications. I know I worked with the SAE and we had the COC certificate of competency, which Ken, I think you took that.
I did.
And there was a little bit of rigor in that one, but that's not really was not a mainstream type of certification. I know that you're working with a grant from the NSF, and which we're both involved in that, the NEVTEX grant, and which is going to provide some rigor to electric and hybrid and plug-in fuel cell programs. So the rigor that's not there today. So I think it's being developed right now, but I don't think there's anything outside of ASE L3 and the former SAE COC program. I don't think there's anything, I'm not aware of anything that's outside of that right now for certification, but it's being worked on. I know that it's quickly being ironed out.
We have a question is from one of my former students, a friend. We talked in our classes, and we still do, that OBD3 generation where vehicles, computer systems will monitor emission diagnostic and do reports outside of the car. And you're familiar with this design. You've talked about it, and you've whether better or worse. Do you anticipate this technology being integrated into new vehicles, maybe somewhere around year 25?
Yeah, for lack of a better term, we'll call it OBD3. But the answer is yes, and I'll confine my comments to electrics in that because how that's applied over to gasoline and diesel is going to be a little different. But yeah, I fully expect that the data crunching to continue where there's going to be more data available. And quite honestly, my concern with that is the technicians and even instructors being overwhelmed by the amount of data that will be available and then how to use it. That's really the key. I mean, you can crunch, I mean, these systems can crunch all kinds of data. I mean, we can get all kinds of numbers and it's great stuff, but unless you know how to use it, unless you know what's going on behind it, it really doesn't help you much. So I think there will be an OBD3 or derivative of that for sure. It's going to have to be there because there's going to need to be more things that are going to be tracked or need to be tracked by a technician for sure. But my concern isn't that. My concern is, do they know how to use it?
I'm going to ask the next question here, and this is hybrid electric vehicle technologies right now are so manufacturer specific. There is little commonality between manufacturers in regards, and same person is talking about the Rio Hondo College Tesla training, which there are 6 of those centers. And I think we go ahead and make those comments. I may have to shut this off until we get through the next section.
Sure. Well, I think if you look at it from ground level, they look different. And I think once you get inside of them, they are very similar when you get inside. In other words, if you look at whether it's a power inverter or some other type of thing, they all are very similar the way they operate, and the way that they're architected inside. Yeah, some of the technologies are a little different inside. Some are more efficient than others, but I think that when you, saying it's OE specific, I agree with that. Some things are located in other parts of the car or on the car. They look a little bit different. Their physical appearance is different, but what they do and how they do it is very similar. And this is where we have to get, I think, as an industry, is we have to get past the point of looking at OEM specific, because once you go a level or two down underneath that, there is a lot of commonality between them, whether they're Tesla or who they are. Tesla's got some unique things, but quite honestly, when you look at how they operate or how the things do what they do, it's very similar. So I would say that our industry needs to where we need to start is, don't look at the OEM specific stuff, where things are located and how many bolts are holding them down and how many wires they got coming out of them. Don't look at that. Go to the next level down and take a look at how they're doing what they're doing, and what they do, and then what kind of data you can look at. And it really closes the gap very quickly on differences between the OEs. When I was at GM, we did plenty of benchmarking of other companies, whether they were Toyota or Honda or whoever they were. We bought their cars every year. The new ones that came out with different systems, and we tore them down right down to the bolt. We had a center. It was called the Knowledge Center, that they took vehicles in, and the vehicles were stripped right down to the last bolt, and you could look at every single thing that was on that car. And so yeah, some of the stuff looked different, but when we start working with it, a lot of the stuff was very similar in nature. So the way I'd answer it is, get to know the technology underneath it first, and the product specific stuff then becomes really easy. Learn the technology first, the product specific stuff second. Don't try to learn it the other way, because if you do that, it'll take you 5 times longer.
Let's go ahead and stop there for right now, Mark, and take it away from the other half.
Okay, cool. Thank you, Ken.
Maddie,
Okay,
are you there we go.
Okay, great. So let's take a look at the training paths then to master the technology. The first thing is that you've got to take a look at maybe what we would consider introductory level areas, intermediate areas, and then areas that would be more advanced. So as an example, introductory level would be things like, the safety systems and PPE, that's personal protective equipment. Quite honestly, I don't know of many courses that really go into the vehicle safety systems like they should. There's very little on there, and understanding how those work, because they can affect if you lose propulsion on the vehicle or not. So it's really important to know those. And then the hardware stuff, kind of where the components are located, and maybe a little bit of DNO, which is description and operation, a little bit of that. That would be introductory level stuff. Getting into intermediate, I would say that you get into more of the maintenance side, and then servicing the high voltage systems, doing some servicing, whether removing and replacing components, things like that. But then you get over into this other area over here, which is going to be getting into DC and AC power. And this is not 12 volt DC. This is high voltage DC, and this is high voltage AC. So this is high voltage DC and AC. There needs to be somewhere in the curriculum, there has to be somewhere where the students are getting introduced to this, because if you're going to look at system diagnostics and creating some processes of your own that would augment what the OEM gives you, you got to know how to work with these systems. They do operate differently. They are very different. Even the high voltage systems are very different than 12 volt DC. I know it sounds like it's, it should be the same, but when you start getting to the high voltage systems, they do different things because you have more potential. So there's a lot of other things that can happen. And then AC is what it is. It's alternating current, and being able to look at whether it's waveforms or at least understand what they do is critical for any diagnostic or repair. Then you get into advanced level, and this is where it gets a little trickier in that now you want to get into electronic devices, software, and then vehicle networks. So the networks would be like your CAN network, whether it's low speed, mid speed, high speed, your LIN networks, things like that. The electronics would be, diodes, transistors, chips, things like that, logic. And I'm not talking about what's been taught in schools typically. I mean, talking about really devoting time to this because it really helps understanding, when you have failures, what does that do to the circuit when some of these chips fail? Because sometimes chip failure isn't complete failure. Sometimes they are within a hysteresis area, like, between good and bad, there's this, in between band, and sometimes they'll fail within that band. What can that do to a circuit? Software writing and coding, again, I'm not trying to make people software people. What I'm trying to do here is, if at least you write software, writing means, hey, what do I want this thing to do? And then coding it means you're actually using syntax to code that, what you want it to do, understanding the software, having a working knowledge of what that does, having a working knowledge of electronic devices, and then having a working knowledge of networks is really going to help in the future. And I would say today, I mean, it's not just the future, it's today. So this is what we're not doing today. We are not doing any of this today. And I know that I probably get some arguments from some instructors and maybe some schools that say we're teaching this, but I've been around a little bit and I haven't really seen much of this going on right here. I know that there's, you teach networks maybe in a class, but I'm not talking about that. I'm talking about really teaching the networks, because the car is basically, it's a computer on wheels. It's an iPhone on wheels. That's what they are. And understanding how those networks do what they do. Understand what those messages mean, how the messages are structured, because someday your technicians, and they could be doing it today, but it's not typically offered, but they can use any type of CAN tool to reverse engineer a message and try to figure out if something's actually working or not. Even though we don't teach that today, it helps to take a look at the messages, because at some point in time, your technicians may be working with the actual CAN messages, and they're going to have to know what those things mean and what they, when something is strung out, what does that mean? So right now that's not being done. And then we get into more advanced level. This would be like waveform analysis and things like that over here. And then also getting into things like when you get into concepts and methods, this is things like, okay, the car is doing this, and what can I do to manipulate the car to see if this thing is working or not, or what signal can I inject? Is there something I can inject into that circuit to make it do something? Is there an electronic device I can hang on the circuit to smooth it out or make it do something? When you get into the diagnostic side, it's understanding what's going on so you can manipulate something. Maybe you want to find out or confirm something. You want to be able to do that. And if you don't understand how these things do what they do, you're not going to be able to do that. It's impossible. We've been doing it for years with, internal combustion engine cars. We know how to manipulate a lot of things. I mean, if you want to lean out an injector or fatten up the pulse without an injector, or if you want to do this, that, or the other thing, you can do it because we've learned how to do those things over time. As of today, we don't know how to, I'm speaking from just the industry as a whole. We don't know how to do that today. And we're going to need to do it because we need to know how to stretch the conceptual stuff and the manipulation stuff so we can interact with the circuit and know what to do with it to confirm a repair or maybe to override a system so that you can see how it reacts and so on. So these things are extremely critical. Then you get into the educational challenges, and so I would say that the educational challenges really are in three buckets. I would say that you got some root elements up here that are really understanding low voltage and high voltage circuits. That's how they interact, because a lot of times they interact. Sometimes there has to be isolation circuits that are between the low voltage and high voltage systems, and the isolation circuits have to can cause issues with the car. So it's not just the high voltage stuff. Sometimes you have low voltage circuits that interact with high voltage. They have circuits inside of them that have to be operational. And if they're not, then what does that cause if they're not operational? Does that cause intermittence? Does it cause hard faults? What does that do? And again, we'd have to know something about low voltage and high voltage AC circuits. This is alternating current. So this is the first bucket here. The second bucket then would be getting into all these systems, and I won't read these off, going from battery pack all the way back around over here to regenerative braking systems. I mean, understanding this is just critical on how these things work. You can look at a scan tool and you can look at data, and that's fine, but if somebody's just looking at data on a scan tool and they don't know anything about the system, that's one thing. Somebody looking at a scan tool and knowing what the data is telling them is a completely different thing. And right now, at least in my opinion, I don't think today that the field is even close to being able to do that. I know that there are some people that have been working with hybrids for 20 years, and I appreciate that. But quite honestly, that doesn't mean that they really know what's going on underneath. And we're going to need to know more about these things, what's going on underneath the shell, if we're going to really get to the point where diagnostics are going to be a firm skill that the technicians can actually do. And then, of course, you get into this side over here. Now you get into the diagnostics over on this side, which are now using scan tools. You're using offboard tools. There's plenty of offboard tools to use. Typically dealers don't use it because dealers aren't really structured to do that type of thing anymore. But the aftermarket really hasn't embraced that yet. But there's all kinds of different tools that you can use, whether they're tools for CAN or whether they are other offboard tools, whether they're scopes, current clamps, other things to manipulate the system. So I think these are the three buckets that we've got, and eventually within training and education, we got to be able to solve the issue of getting technicians to march through these three buckets here. I'm sure you could probably put sub buckets in here, but these are just kind of the three big ones. Then there's mastering. How long does it take to master this? So when you get into hybrids, electrics, and fuel cells, how long does it take to master? Well, we actually studied this at GM. We actually studied it from 1997 through 2010. And I was part of this, and we started with the EV1 program and worked all the way up through like the Chevy Volt program. And what we found out is, and I won't go through the whole thing here because you guys can read it on the slide, and this presentation is going to be available in PDF through Clean City's website anyway, and there may be some other places to get it, but I know that Brian has, I think Brian and his crew are going to offer this as something you guys can get a hold of, but it goes all the way from month 1 through 12, going all the way through month number 60, which would be like year number 5. These are typically the steps that people go through that we noticed going through year 1 through 5. And this is with people, by the way, the people that I'm talking about here that we looked at, whether they're engineers or technicians, because we looked at both, and there's really no difference between them. They really kind of go through the same thing. And when they're trying to learn the systems on there, we found out that they go through these iterative cycles where they get comfortable and then they start learning more, then they're uncomfortable. Then they master that, they go on to something else, and they're uncomfortable with that until they learn it, and then they get on to the next thing. It typically took them about 5 years to really master it. And these are people that were working with these vehicles almost on a daily basis. And this goes from everything from removing nuts and bolts all the way down to monitoring CAN signals and working with computers that would give you bidirectional controls and things like that. And then also this would be manipulating systems and so on. So it really depends on the background of the person coming in. Some of them may not take 5 years. Some of them may be 3 years. We had people that came in that had very good backgrounds in power electronics. It took them less time to master it. And then we had people that had zero background in electrics and hybrids. It took them the full 5 years. And this is working with these almost on a daily basis. So I think it's one thing to be able to do maintenance on these vehicles and maybe doing a little bit of R&R, removing components and things and looking at trouble codes. It's a whole nother thing when you're going to be really delving down into it to figure out a problem that's absolutely driving you nuts. And so this is what we found out anyway at GM. This is 97 through 2010. So it really can't be mastered overnight because there are very different things you have to learn along the way. So this gives you an idea right here. I'll just throw out an example. This is a simple Ohm's law circuit. Now, instructors that are on this seminar here today or this presentation know that Ohm's law is a very linear equation. It's actually pretty simple to figure out because current's going in one direction. You know, the source voltage doesn't really change too much. So you could actually pretty much figure out what the voltage drops would be across these at any point in time. This would be pretty simple. If I take the capacitor out, if I just took the capacitor out of this and just made this a straight line right here and got rid of that, you'd have 12 volts, you'd have 12 ohms. So you would know that you have 1 amp flowing in that circuit. That's pretty simple. Ohm's law is pretty straightforward. However, when you move over to AC, because alternating current is constantly moving, you can't use the same philosophy. We could take this right now and say on Ohm's law, if I get rid of the capacitor over here and just make this a simple series circuit, I could say that I'm going to have a 10 volt drop across that resistor and I'm going to have a 2 volt drop across that inductor. And according to Ohm's law or Kirchhoff's voltage law, we know that, 10 plus 2 is going to give us the source over here. That's a straight up Ohm's law thing. And that's good. We know that. In fact, if I were to ask anybody who's an instructor or a technician that is at least has some moderate level of competence in it, I could ask them, if voltage goes up or down, what happens to current? If resistance goes up or down, what happens to current? And so on and so forth. And they may be able to tell me what that relationship is going to be. And that's good. You want them to know that. But when you get into electric car and you get into alternating current systems, it's also good to know what's to be expected from that when voltage goes up or down, or in this case, when frequency changes and things like that. So let's take a look at something that's AC here. Now, this is a circuit that has a 100 volt source. It's running at 50 hertz of frequency, and I've got a resistor, I've got an inductor, which is a coil of wire, and I have a capacitor in here. And so when I look at that circuit at 100 volts and 50 hertz, you can't use Ohm's law to figure this out because A, you've got a sinusoidal waveform going through here. So your current, your voltage are changing all the time. And then B, your frequency right now is fixed. But what happens if the frequency goes down to 30 hertz or it goes up to 800 hertz? What happens to the circuit? Well, let's just take a look at this for a second. So if I were a technician and I were looking at this circuit and I have 100 volts being applied to each one of those components, and it's being applied at 50 hertz, here's the voltage drops that I have across each one of those devices. Now, I know this looks odd, and you're going to say, Mark, this is impossible. No, it's not, because in an AC circuit, because you've got something called inductive reactance, which is X sub L, which is right here, and you have a capacitor in here that gives you something called capacitive reactance, it changes the operational character of that circuit. So in this case, I've got a 61 volt drop across the resistor, a 242 volt drop across the inductor, and a 163 volt drop across the capacitor, but I've only applied 100 volts and I'm at 50 hertz. So if I apply a different voltage, let's say I go to 200 volts and I go to 100 hertz, that completely changes the voltage drops across each one of these. In fact, if I keep it at 100 volts but just change the frequency, it changes the voltage drop across the inductor and the capacitor. So again, when you get into AC circuits, and this is an RLC circuit, and RLC means that it is a resistor, inductor, capacitor circuit. And it's really critical to understand if the voltages go up or down, or the frequency goes up and down, how does that affect the circuit? If I'm going to take a measurement, how does that affect it? Or if I want to manipulate the circuit, if I inject something into a circuit at a higher frequency, what do I expect to see coming out the other side? So if I want to confirm if something's really doing what it's supposed to do, how do I do that? You're not going to do that unless you understand the relationships. And the relationships of DC and AC are wildly different. And right now in the automotive space, at least from what I've seen over the years in dealing with either in the education space or training space, there is very little time devoted to anything on AC. And this is exactly where these systems live. And it doesn't matter if it's low voltage AC or high voltage stuff. It really needs to be understood. And I'm not saying you got to calculate numbers. That's not what I'm saying. Understanding the relationships of AC should be the same thing as understanding the relationships in DC. So understanding Ohm's law is really good in electrical. You got to understand that because those are relationships of voltage, current, and resistance. But the same thing has to be done with the AC side. Again, it's not about crunching numbers, it's understanding relationships. But in order to understand the relationships, sometimes you're going to have to crunch some numbers to do that, which means the technicians are going to have to get into a little bit of math. I'm not saying that they've got to go hog wild into trigonometry, calculus, differential equations, and more advanced math than that. What I am saying is we need to teach them the math so they understand the relationships. That's my opinion. Okay. Having a working knowledge of electronic devices and software, I think the structure software is critical for enhancing diagnostic prowess. So I think electric vehicle technicians or anybody in electrification needs some type of skill in electronics and networks. And this would be more the hardware side, whether you're talking about the symbols over here going all the way around to selection of components. And I'm not trying to make them the designers, but what I'm trying to do is get them to look at components so they can see by looking at a data sheet, they can see what that thing will do and what it won't do. There could be some employers where your technicians, once they graduate and go out, there may be some employers that are electric vehicle centric that may want them to be able to unsolder components out of a board and solder components back in, and then also tasking them with being able to use technology to be able to find out if that board is working correctly or not. Selecting components. I know this may sound far-fetched, but this is where we're going. I mean, we're getting out of the mechanical space and we're moving into the space of electronics and software. Typically, we've been able to ignore this over the years. For 125 years, we've been able to ignore this. We can't do that anymore. So we're going to have to be able to get into these areas in electronics and networks and increase the skill. The techs, and I think even instructors, have to be able to acquire those skills. On the other side, on the software side and on the firmware side over here, and I don't want to go into the depths of the differences between the two. We'll leave that for another time. But what this does when you're writing and coding software, it forces you to focus. It forces you to develop creativity, attention to detail, how to manipulate, develop logic, systems flow, diagnostic processes, and construct solutions. I'm not saying that techs or instructors have to be coders, software writers, electronic engineers. That's not what I'm saying. What I'm saying is if you have a working knowledge of this, it almost forces you to become a better diagnostician, because once you understand the flow of it, once you understand what's inside of it, it's automatic that you become a better diagnostician with it. And there's no way around that. I've had technicians over the years in courses that I've taught, and they'll come back to me a year or two later and they'll tell me that even though they're not coding software, even though they're not writing it, even though they're not, getting into, specking out components, it's made them a better diagnostician because they're viewing the data differently, and they're using different skills now that they learned in order to manipulate or confirm or doing something with the circuit. So it's really important, I think, that technicians, instructors, and I think the administrators really need to understand where this is going, because if they haven't been keeping up with what's going on in the automotive industry, they are far behind on what their students and their instructors need. Okay, so let's take a look now at advanced systems requiring a working knowledge. I work with a company called Future Tech, and we offer electronics boot camps, and they're on 2 levels: fundamental level and intermediate level. And there are others out there that I'm sure do the same thing. I'm just telling you what we do so you get an understanding of what's out there. On the boot camp here, the fundamentals one, we get into electronic devices, we get into writing and coding software, reading data sheets and so on and so forth, manipulating circuits and things like that. This is just a fundamental, just to kick the door open. Then in the intermediate side, what we do is we continue with writing and coding, but now what we do is we start doing data bus work, and we actually start networking modules together, and we do a lot of ADAS type of work in here. We have things like LiDAR, ultrasonics, we use infrared, we use proximity sensors. And so we actually will write the code and then calibrate those devices so that they can pick up, whether it's ultrasonics, they can pick up something where, that's what you've had on cars for years, is ultrasonics, like on your bumpers, for telling you how close you're getting to something. We'll actually code those and then calibrate them and so on. But it also gets into data bus work a little bit with that, because a lot of these things are modules, and they all have some type of hex type of address on them that we have to go to address them and grab the data from them. There's also other things we do in here: voltage to frequency conversion, or voltage to current conversion, things like that. We do that in the intermediate. So I think, to answer some of the questions that the people have had, are there things out in the industry? Yeah, they are. You just have to find them and find companies that are credible to do it. But this is the way that I've been doing it with Future Tech, and we've had some good success in it. It won the ASE Training Award in 2019 for that. So we're pretty proud of that. But this is just one place. There are other places to get it. There's tech schools around, that you can get that from. This boot camp, the fundamentals, is a 5-day class, and so is the boot camp. And there's also a project at the end of the class, and each class has a different project to do for demonstrating competency. So there's lots that goes on in that. So there are places to get this background, whether it's from a company like Future Tech or somebody else that's got a tech school or whatever. Just make sure that they're competent in what they do. Also, taking a look at devices and software controls. This is just a really, really super simple model of electronics devices and software controls. So if you take a look at this loop right here, you've got hardware and software in here. Of course, you got the microcontroller here, that's kind of the center, and you've got software that's or firmware that's looking at that. And you've got interfaces, which would be your signal conditioning. So you've got your controller that needs to talk to the outside world, and you have to use something called signal conditioning. And we teach that in our boot camps as well, what signal conditioning is, analog to digital conversion, and then vice versa. Of course, you got your outputs, which would be your motors, your relays, your LEDs, and so on. You got inputs coming from transducers, sensors, or whatever they are. They have to go through some type of signal conditioning. So whether you're going into or out of the controller, you have to have signal conditioning to be able to talk to the controller. So these are things, I think, that are fundamental, that need to be implemented into any type of education or training program. That's my opinion. You may get varying opinions from that, but I'll tell you, after being around this is my 33rd year in vehicle electrification, and quite honestly, this is the stumbling block. when you get away from just the traditional automotive and you start getting into alternating current circuits, you start getting into controllers and software and reading PIDs and being able to manipulate and so on the circuits. This is where it really falls on its face here. This is the roadblock. And we have to get our technicians past this roadblock, because this is what they're going to be working with. The mechanicals are going to be kind of slowly going away, and the electrics and the software and the electronics all come in to replace that. So there's going to be something, there's going to need to be something on new certifications, even licensing that should be considered. Right now, you've got the model that we have today is pretty much certification, but there's no demonstration of competency. So right now, today, as an example, you've got the ASE, which is you take your proctored exam, but quite honestly, if you can pass the test, you get your certification. The SAE, which I was involved with, we still have something called the Certificate of Competency, but we're also working with something called the NEVTEX grant, which you can certainly contact Ken Mays more about that if you want to know about it. The SAE is working with that grant, and the SAE is serving as feedback for the grant, but they're also serving as a certification body to certify. This would be both proctored exam and hands-on. This would be quite different. The ASE currently doesn't do anything with a hands-on certification, but what we're looking to do with the NEVTEX grant, coming out of that grant, would be certification of technicians, and there's even a licensing component that's being tossed around right now for actually licensing, because it is high voltage. There are some quite some differences in that, and so that's being looked at. Or there may be something else that we're not even thinking about right now. But I think there needs to be something that recognizes technicians that get that certification. And part of that might be in the opportunities that are coming between 2020 and 2040. I think you can probably put these into three different buckets. One would be, I think there will be some technicians that will stay with the traditional side of the business. They will not go into electrification for whatever reason, and they will stick with traditional stuff, and that's fine. I think that there may be a new category of technician that comes up at some point in time. This is just my bent on it here, but it could be called an automotive engineering technician, in which you recruit your really solid electrical and drivability technicians. You put them through some education and training in electronics, network, and software and firmware, and then you completely change their pay structure, because it would need to be that, because when you get into, as many of you on this webinar probably know, that when you get into electronics and electrical, it's a by hour thing, and you can't always find things, and not everything's flat rate. And I think that probably has to change even for traditional techs, but in this especially, they'll probably have to be put on some type of pay structure, whether it's salary or hourly. And then the third one, which I have heard bandied about now for the last 2 or 3 years, is there's a whole new business model that's being looked at, that there'll be specialty shops that'll pop up to do network stuff, electronics and software on VE products. There could be startups that do this, that will cross-train. OEMs may end up subletting, and the aftermarket, by the way, may end up subletting to these specialists. And there may be a franchise that's created, or a services that are added to an existing franchise. So again, if the technicians want to get into this, it's probably going to be a more rigorous process. The pay structure is probably going to be different, and the recruitment's probably going to be different too. They're going to be looking for people that have solid backgrounds in automotive already, and I'm talking about electrical in nature, and then being able to train them the rest of the way. I think this is coming. These are just my opinions, but I see this coming. I have heard conversations of industry leaders around this right here, making a different model that will completely open up new businesses, that will go where maybe the aftermarket doesn't want to go, and will go where the OEM dealers may now want to spend the time to go. Okay, so this is what I see. Big picture for technicians, probably even instructors, quite honestly, is I think that the technicians will have multiple career pathways. I think because all these areas, whether they are light duty here, medium duty, heavy duty, aircraft, marine, forklifts, or even stationary power, all these pathways have the same technologies underneath them. They all have battery packs. They all have, most of them anyway, have motors. They all have some, 3-phase, 6-phase, or 9-phase motors. They have power inverters. They have safety systems. They have DC to DC converters. They have all the same stuff. So I think that there may be, unlike our current model, which if you're a diesel technician, you're going to be into, the diesel engines. You're going to be into 5, 10, 20 speed transmissions and so on. You're kind of siloed there. I think in the future, and it's not going to be too far down the road, which I think technicians will have the opportunity to go across different disciplines because the underlying technologies are going to be the same. So I think there's going to be a lot of changes in the transportation space. So I think in the future, at least my opinion is, we have to start changing how we look at transportation. It's no longer going to be siloed anymore. I think it's going to be expanded, and there's going to be plenty of opportunity across different disciplines. That's the way I see it. I'm working with OEMs and remanufacturers and working even in the aircraft space. And I can tell you that a lot of these same things that you would learn in automotive could be ported over to aircraft or marine or somewhere else, anything that's got electric drive. Okay, and I think that opens it up to Q&A. I may have run just a little bit long. I apologize for that, but hoping that's okay. So I'm going to turn this over. Yes.
Here we go. This is a carryover question from the first half. When you touch upon the battery composition technology of NCA or NMC, this seems to be one of the most dramatic facets of the possible single best design and content of the best 21st century battery. Question, is it possible for you to comment, to take a moment to compare the contrast the technology edge that keeps both nickel metal, nickel metal aluminum and nickel metal cobalt, as well as other similar variations? And lastly, is there one battery technology that is expected to dominate at a very soon stretch here?
Okay, that's a huge question that's going to take a lot of time. Let me see if I can skinny it down here. Currently, NMC is the mainstream technology, although not everybody uses NMC because it's got good energy density, good power. NCA, which is what Tesla uses for their mainstream battery, has got more energy density in it, but it's less stable. So as you go toward using more metals, you end up getting into instability. So NMC is the mainstream, but that's the flavor of the month today, right? I mean, that's what it is. And NCA, same thing. But what you're going to see in the future is you're going to see batteries that are using different metals, moving away from cobalt. There are several reasons for that, but moving away from cobalt gets more stability into the battery. And eventually we're going to end up with solid state battery, which is really where you want to go. Solid state's going to give you 2 to 3 times the energy density. It doesn't have any of the stability problems of the current lithiums that are using electrolyte in them, liquid electrolyte. That's organic stuff that's what causes the problems with lithium if you want to talk about thermal events or fires. But once you get into the metals, when you start putting the metals in, rather than getting away from the carbon graphite, that's really when you get into cars that will have ranges that are going to be rather extensive. Once you get past using carbon graphite, you can get into batteries that last much longer. There is hype right now with Tesla claiming to have a 1,000,000-mile battery. There are others that are working on that same thing. So the battery, even if it goes half of that, even if it went 500,000 miles and not a 1,000,000-mile battery, you'd outlast the vehicle. And then what you do is take those batteries out of the car, then you put them into stationary power or something else. So the life of the battery is going to change a lot over the next 5 to 10 years in what it's going to be used for and how it's going to be used. I know that's a short answer, maybe not have answered everything. and I apologize for that, but that is a huge question. But solid state is going to end up winning the day. And then what's after solid state, who knows?
When a vehicle comes into your stall and has no driver, what are we going to do?
It has no driver, so what are we going to do?
Yeah, so a driverless car comes into your stall for the first time.
As long as it's got a port where I can hook up and get some data, I'm going to be halfway there. There may be, don't know, this is like way off into the future, but just because the car is driverless doesn't mean that there won't be a service process in which you can work around that to be able to test the car. It's going to all be about software. It's going to be about using tools to interface with the system. I mean, that's, you know, if it has a steering wheel, it still has data. If it doesn't have a steering wheel, it still has data. I mean, to me, whether it has a steering wheel or not is irrelevant. At that point, I just need to see the data and start testing the system and manipulating to find out what it'll do. I don't even know why the car came in. If the car came in because, the regen braking turns on whenever it wants to, or it decides to take a left turn, you know, anytime it sees a buffalo in front of it, you know, something like that. Those are all things that you have to test for. A lot of that has to do with ADAS because, you know, ADAS systems are electronics, they're cameras, LiDAR, ultrasonics, all that. But I don't think it's going to be difficult if somebody's got a good background in electronics, software, and just understanding how those things are networked together. I don't think it's as difficult as it might appear. Right now, it's the boogeyman in the closet because it's the new thing. But if you have underlying skills that can work with that, it really won't matter.
We've got a question on local community college electronics courses, not automotive specific. Do you think those would be helpful for automotive instructors understanding AC and or electronics?
It is, but what I'll do is I'll caution you because I've worked with that before. I've worked with trying to marry up industrial electronics with automotive, and the issue is that a lot of the industrial stuff, and it should, it pays more attention to stuff that comes out of the wall, utility power, you know, that type of thing. And they'll spend a lot of time on that, power supplies and things. When you put that stuff on the car, you've got a little bit of a different dimension there because you're not using utility power. So if you take a class at a community college, you have to be able to extract out what you want out of it and ignore everything else. That's the only way to say it, because there are certain things like in industrial, you get into things like diacs, triacs, SCRs, those things you never see on a car. I mean, you'll never see that. Those are all AC devices. So when you get into that class, you'll have to ignore that. I know you still have, if you want to pass the class, you have to be able to know it enough to pass a test maybe, and maybe some type of lab exercise. But there are an awful lot of things in the industrial space that wouldn't apply to automotive. So if you do take it, just be prepared that you're going to have to extract things out of it that you want, and you have to ignore everything else.
Larry's asking, he says, agreed, what separates the dealer technician from a FSE?
Field service engineer?
That must be it.
Okay. Hi, Larry. So what separates the technician from the field service engineer? Usually it's one of a couple of things. Usually a field service engineer anymore, if they work for the OE, they have to have some type of educational background, usually at least, typically today, most of them want 4-year degree. Automotive technology is usually probably the baseline. It's not everybody that does that, but a lot of the OEs now have pushed toward that. But I think in the future, because automotive programs don't really teach electrical real deep, and certainly not AC electrical and not electronic devices and so on, I think they'll start taking people that are, they'll have a combination. They may have a 2-year degree in automotive and then a 2-year degree in electronics or networks, something like that. I see that changing. I would much prefer somebody, if I were going to hire somebody as an FSE, this is what I'd have. They'd have a 1-year program in automotive 1 year in electronics, 1 year in networks, and 1 year in software. That's 4 years, not a degree, but completely different disciplines, and they'd probably serve me better than the guy just with a random 4-year degree.
I'm going to combine the next two things. When my friend Gordon asked about agricultural equipment integrating this technology, but Marvin is asking a question here. Diagnostic electronic tools, i.e. battery balancing, inductance and capacitance, voltage, etc.
Yep.
Analysis are numerous. Are there companies creating new analysis tools that combine most of the EV analysis features? And we'll stop there today.
Okay, so I'm going to answer this. I'm just going to cut to the chase and answer it. If you take a look at how the Department of Energy tests the batteries for the automotive company batteries, if you take a look at how OEMs and even their suppliers test batteries, they use power and capacity testing. That's what they use because it's the most reliable. If you use something other than that, you can use impedance testing, but that's really only good at a new cell level because all that stuff changes once the battery goes out the door. So if you look at spectroscopies or some type of impedance testing, something like that, they're all good when the cell is new. But if you really want to check the dynamics of a battery, you really need to power test it, which is typically anywhere from a 5 to 10C test, which is 5 times its capacity or 10 times its capacity, depending on the battery size. And then you do capacity testing, which is discharging the battery. And sometimes that may involve some rather elaborate algorithms to discharge. That's the only way to do it. So you have to find companies that will have load banks that will test the batteries, power and capacity. And they'll also allow you to program in some of your own testing. In other words, if there are specific things you want to do that. That's at the OE level. If you're in the field and doing battery balancing and stuff like that, there's a lot of things there you don't need. What you need is something that does power testing and capacity testing. And power and capacity are two completely different things. And if you don't test both of them, you're going to get yourself in trouble. So I'll leave it at that.
Mark, I'm going to conclude the question and answers and applaud you for an outstanding job today. And thank you again for taking your day or week to prepare for this and present. We are all better for it, and we're looking forward to additional times ahead. We are talking about another seminar to talk about the boot camps. We're also other resources of equipment. Some of the instructors, companies are interested in those things. So thank you again. We'll come back.
Ken, thank you very much. Thank you to Clean Cities and Brian, and thank you, Ken, for moderating. And again, thank you to Maddie Resnick for managing this. Much appreciated. I enjoyed it very much. And anybody here can contact me at any time. I think my email and that was on there somewhere. So anytime. But I enjoy this and really like to see the industry start moving or transitioning into the electric side. Appreciate it. Thank you.
Thank you. Thank you from everybody. Hey, everybody who's still on the call here, we're moving our seminars to Fridays at 1 o'clock. And the next one will be September the 18th on ADAS Foundations for Technicians. It's going to be an ongoing conversation. Hopefully everybody can make it and add more people. Tell folks that you know. So that's a big deal. So get ready for the next series, and we will see you again.